All right, well, thanks, Larry. We've got a number of mortality disposal options in the state of Nebraska, and regardless of how well an operation is run, unfortunately, dead animal disposal becomes part of the mix. And so within the state of Nebraska, like I said, we've got 5 different options: burial, on-site, rendering, of course. We can transport off-site to a landfill, composting, and incineration. So why are we talking about composting today as opposed to the other 4 options that are available? Not necessarily because composting is any better, but we've had some changes in the state statute as far as the size of animals that can be composted. And so that's the basis of this talk today, is discussing what those changes are, and then if that's not something you've been using in the past, kind of give you a short course on how to compost mortalities. So what we've seen changed, let's see if I get my pointer to work. What we've seen change here recently, it used to be that there was a restriction that you could not compost animals that were greater than 300 pounds. And here recently that's changed to allow composting of animals, or changed recently to 600 pounds, and then now that limitation has been removed altogether. So any size livestock mortality can be composted. And there's really no magic to the number as far as the weight of animals that can be composted. Surrounding states have composted mature dairy cows and horses for years, and I haven't been here long enough to know kind of the reason behind the limitations in the past here in Nebraska. The fact is now there's no limitation on size, and so composting is available to all livestock producers. Basically, the majority of folks in the state, I would imagine, are using either burial, composting, or rendering at this time. So, we'll focus on composting here, and if there are questions on the others, then I'm happy to discuss those as well. So why consider mortality composting? Not to say it's any better than any other method of disposing of mortalities, but perhaps you don't have access to a rendering facility or a landfill that would take the animals. Cost may be an issue. If you are typically used to using burial for disposal, maybe that's not available because of the time of year, the ground is frozen. Perhaps you're in an area where the groundwater table is too close to the surface. You can't bury animals because of that. Or maybe it's a biosecurity issue. Maybe you don't want a rendering truck coming onto your farm that's been on other sites. So for whatever reason, maybe composting seems like an appealing option for your particular farm. Now there's definitely pros and cons, just like any other activity for getting rid of animals. On the good side for composting, it's relatively inexpensive. Most operations are probably going to have the equipment they need on site, the materials needed for building that compost pile. It does produce a valuable soil amendment, and so when you've produced a good compost material at the end of that composting cycle, it's something that can be applied to your fields, has a nutrient value, improves soil health. It's also biosecure from the standpoint that it's all contained within the farm, so you're not having to have other people on your farm to collect the animals. You do it all right there and keep that animal and that compost material on the site. And it's always available. You can compost in the wintertime. It may be a little bit slower starting a compost pile, but it's certainly, we've seen in some trials that we've been doing here in the state that you can start a compost pile successfully in weather like we've had over the last few months here. As far as the drawbacks of composting, it does require some commitment on your part to operate that. It's not something you can go start and leave and expect to come back in 3 or 6 months and have some beautiful, rich, organic material to put on your fields. It does take some dedication on your part to manage that. It does require some dedicated space on the farm. We'll talk about space requirements here in just a little bit, and when we talk about site a new composting facility. And it may require some land preparation prior to starting. So nothing too major, but that's something to keep in mind as well. So what are the tools that are needed? Like I said, it should be equipment that you already have on the farm. If you've got equipment available for hauling mortalities, you know, if you've been burying them in the past or moving them for a renderer to come pick them up, then you've probably got the materials or the equipment that you need for composting. Basically need a tractor with a bucket or some other implement that you can move those animals with, create the pile, move the materials that you need to build that pile, and then be able to turn the pile at various stages throughout the process. Another item you'll want to have is a logbook. It doesn't have to be anything fancy like we show here. Something, you know, just a spiral notebook, something where you record temperatures of that pile, when you've added moisture to it, weather events that might impact, so whether you've had rainfall or whether it's been dry and you've had to add moisture, just kind of the basics of keeping track of everything that goes on around that pile in that area. And probably the one thing that most people have to go out and acquire would be the temperature probe. Unless you've done some composting in the past, you probably don't have this. And it's a little bit pricey, around $150. It's kind of your typical analog temperature gauge, but it's, you know, we want you to have one that's about 36 inches long so that you can stick that into the middle of the compost pile. So not your typical meat thermometer. It's going to have to be something special, and those are a little more expensive. As far as the materials needed, again, we don't expect producers to go out and purchase sawdust or wood shavings or that sort of thing. You expect that you would have the materials on farm to do this. And so usually what we recommend is you want to have a carbon-nitrogen balance that facilitates the microbial activity that's required to successfully compost that carcass. So carbon sources could be bales of hay, you could have corn stalks, feed refusals, spoiled feed, you know, any of those sorts of carbon materials that you would have on the farm. And then manure is a great source of nitrogen for helping get that pile started. So usually we look at a kind of a mixture of manure and some carbon source as forming the basis for your compost pile. So then the choice is whether you do it as a bin or a windrow. There's not a whole heck of a lot of difference as far as how they operate. The design is a little bit different. With a bin system, it could be something as simple as a three-sided enclosure where you're using round bales to block in those three sides of the area. It might make it large enough for one animal or two or three, however much you decide you want in one spot. With a windrow system, and this is kind of a simple windrow system here, you can see three distinct mounds. And what this is the site out at the Nebraska College of Technical Ag out in Curtis, where they've been composting mortality since last May. And so the first mound here was the first animal they placed, which was, I believe, a 1,500-pound beef animal. When they had the next mortality, they just came right next to that, built the next mound, and so on down the line. And I think at this point there are 5 animals in there, so you just kind of keep extending that windrow each time you have additional animals to put in it. And so not a whole lot of difference, of course, in how you build it. It's just whether you kind of keep a group of animals contained in a bin type system, or whether you make kind of a long windrow out of that and just continue to build the pile each time you add an animal to it. So site selection and preparation. This is these recommendations are from the Nebraska Department of Ag. So the Nebraska Department of Environmental Quality regulates you know, your nutrient application, your permit on your animal feeding operation, and they're the ones who regulate burial and incineration of animals, but composting is regulated by the Department of Ag. So they have a set of standards, and that's there's a printout in your proceedings booklet that you received that talks about their requirements. So these are some of the basic things that they require. One is that you keep your composting site separated from sensitive areas, so wells, surface water, ditches, anywhere that you wouldn't want those nutrients to either leach to groundwater or run off and get into surface water. And so a 300 feet setback distance is what they recommend. The other is that you choose a site that is, has a gentle slope to it. You don't want water ponding around your compost pile. That will cause you problems with having too much moisture in your pile. You want the leachate, if there is any, to be able to drain away from the pile a bit, but you also want to be able to contain that. So you may have to grade the site a little bit to get that slope. You may have to build some berms upslope from it to keep surface water from running into your pile, and you may need to have some sort of berm downslope if you do have some leachate or some storm water that gets in contact with that pile. You want to be able to contain that downslope. A compacted soil base is recommended, basically for the purpose of if you've got leachate coming out of the bottom of that pile, you want to minimize the seepage of that material into the soil. Ideal, it would be a concrete base, but we don't anticipate that a lot of folks are going to go out and invest what it takes to put in a concrete pad if this is something new that they're trying on an operation. So kind of a minimum is just to go and compact that soil. What we don't want to see you do is use any sort of gravel base, because when you go to turn that pile and remove the material for land application, you can get that gravel mixed in with it, and you don't want to be hauling that out on your site. So either a soil base or a concrete base is preferable. And then if you're concerned about not having enough moisture in the pile, which we've certainly had issues with drought, and particularly for our folks out on the western side of the state where rainfall is expected to be much less, you want to have access to some water source, either a hydrant nearby or a tank that you can haul water to that compost pile to add moisture. We'll talk a little bit more about moisture content here in a bit, but that's an integral part of making sure that system operates correctly. So you want to make sure that you're able to add moisture when it's needed. So look at the pile construction. This is a basic diagram that applies whether you're doing a bin type system or a windrow. So this is kind of showing that first animal that you place into the pile, how that material needs to be placed around it. So the first thing is this base material, and you want to start with at least 24 inches of an absorbent material as your base. Usually we don't put manure in that base part of it. It's purely there for the absorption of any liquids that come out of that animal as it begins to compost. And so 2 feet of absorbent material. You also want to have 2 feet on each side of that animal. So you're talking about a pretty good size base there for a larger animal. One thing to keep in mind this time of year is if it's particularly cold, you want to try to get that animal placed in the compost pile before it freezes, because it will still compost, you will still get that process going, but it's going to be a much slower startup if that animal is cold or frozen particularly. So once you've got that base in place and you've laid the animal on there, the next step is to cover the animal with the compost material, and so this is where we usually would recommend a mixture of manure and carbon source. So whether that's your waste feed or corn stalks, whatever it may be, some sort of mixture. If you're lucky enough to have an existing compost pile, or you've got a neighbor that's composting, you can get some of that active compost material from those operating piles and put that around the animal, and that will help jumpstart it as well. It's already got the microorganisms active in it that are required for composting, so it can help get that process started a little quicker. The next layer then is what we call the cap or the envelope material, and so that is kind of your insulative layer on top. It helps keep the moisture in the pile. It helps keep the heat, insulates the pile to keep heat in, and so you want this to be about 12 inches deep. If it's particularly cold, you may want to go 24 inches deep on that cap to give a little extra insulation. But you want this to be a clean, fresh material, so you don't want manure in this part of it. You can use finished compost material. You could use soil. Both of those will work well. One thing to keep in mind is you don't want it to be so dense that it actually seals off the top of your pile, because you need that oxygen exchange as well to keep those microorganisms working inside there. Something in mind, for every 1,000 pounds of carcass that is placed in a pile, you're probably going to need at least 10 cubic yards of material. So that kind of gives you an idea to plan from. If you have an idea of death loss and how many mortalities you might deal with in a month, that gives you an idea of how much material you'll need to construct those piles. One last point, if that animal that you're placing has not been necropsied, you'll want to puncture the rumen. Or if it's a non-ruminant animal, you'll want to puncture that abdominal cavity so that animal's not bloating and it could potentially disrupt the pile and you'll have a big mess on your hands. So you want to make sure that animal's been punctured before you start the process. If you're having an animal necropsied and you know you're going to compost it, go ahead and move it out there onto the base. Have that base constructed and put the animal on it before your vet comes out and does the necropsy, then it's all right there in place and it's ready to go. When that's finished, you can cover it up and start the process. Okay, so the most important measurement you would be doing to make sure your pile is working properly is to monitor the temperature. And so what we see as a general rule of thumb, your temperature will follow this curve that's shown here. And so during the first few days to maybe a couple weeks, you're going to have a rapid rise in temperature. That tells you that the compost process is getting started, the microbes are working, they're going through their respiration, which is creating the heat and the moisture that keeps that pile operating. You'll have a period where that temperature kind of levels out and stabilizes for a period of several days to several weeks. Depending on the time of the year, during the winter, that phase might be a little shorter. During the summer, it could be several weeks. And what we're looking at as a goal here is to maintain a temperature of about 130, 131 degrees for at least 3 days. And so the reason for this is that we're looking for those high temperatures to destroy pathogens in the pile. And it's not to say that when you're finished, you'll have a pathogen-free product, but what you're do is destroy the pathogens that are at the center of that pile. As you go through the process and you turn the pile and you go through a second heating phase, you expect to get a greater pathogen kill throughout that pile, but I definitely would not say that you're coming out with necessarily a pathogen-free product. Your temperature could get up in the 150 to 160 degree Fahrenheit range, and that's fine. Like I said, what we want to see is at least that 131 degrees. That's our kind of target point. So one of the other reasons we want to keep monitoring temperature is so we know when that composting process is slowing down. And so when we get temperatures that are dropping down into the 120s, then we know that it's time to turn that pile. The compost process is slowing down. We're not going to get much more breakdown of that carcass unless we turn it, add some moisture. We may need to add some nitrogen to it. And so at the demonstration site that we're working on out at Curtis, we're looking at about every 90 days that pile gets down below that 120. We turn it, we add moisture, and start that heating process over again. So here's kind of an example temperature log that you might keep on that site. These are some actual values from out there at Curtis. So for instance, in May, they placed an 800-pound steer in the pile. A week later, they went and monitored at these 4 locations within the pile, and these are the temperatures they were getting. So you can see they were well above that 130 degrees. They took some notes. There was no odor. They'd had about a half an inch of rain. They'd seen the pile settle a little bit. So just kind of basic observations that'll help you come back later if you have some problems and help troubleshoot what the issue might be. Here we're showing into June, a couple weeks later. They had to add a little bit of moisture to the pile. They are starting to drop down into the 130s, but still not near that 120. So it just kind of gives an idea of how that temperature process worked in that pile out there. It is worth noting they put an animal in. We did a demonstration day out there in December on the 12th. At that point, they placed a horse in the pile. 1,200 pounds, I believe, or 1,400 was the weight of that animal. And the temperature that day we were out there was relatively mild, but shortly after that we were down into the single-digit temperatures. And that pile heated up to 140, 150 degrees within a week, and it has maintained that temperature for several weeks. So even in those cold temperatures, we were pretty successful at getting that pile started with a new carcass. So here's just a couple of references for purchasing temperature probes if that's something that you're interested in. And like I said, these range around $150. You might get them a little less expensive at one of these sites, but that's kind of an average price. So for moisture management, again, this is what's going to drive whether your pile is operating properly. You've got your carbon and nitrogen, and you've got your moisture content. So ideally, we want to see moisture around 50 to 60%. So what does that mean? I don't expect anyone to be taking samples and drying them in an oven and weighing them and trying to figure out the moisture content that way. The easy way to tell moisture is what we call a squeeze test. So you're picking up a handful of that material, give it a good squeeze. If there's water dripping out of it, it's too wet. You don't want moisture seeping out of that material. If you squeeze it and you just barely get a little bit of water squeezing out between your fingers, that's what we're looking for. Kind of a wet sponge feel. So if it's so dry that you can't squeeze water out and it's just crumbly when you let it go, then you know you need to add moisture to it. When we turned the pile out there during the demonstration day, it was pretty dry. At that time, they added 200 gallons of water to this windrow that was about 20 feet long. So 10 gallons per linear foot of windrow. Kind of gives a ballpark of what you might expect to add to get your moisture up. You want to add water when you're starting the pile if your material's dry. The other good time is when you're turning the pile. And if you're in the middle of one of those 90-day heating cycles and you realize that your temperatures are dropping, that material is getting a little bit dry, you can always add moisture right across the top of the pile as well. If you're in a particularly dry period or in a dry area, you can kind of make a channel along the top of that windrow that will catch water and keep it in the pile as opposed to shedding it off the surface of the pile. So that's another option. So turning the pile, like I said, once we see our temperatures start to drop and not be sustained above that 130 degrees, then we need to be getting ready to turn the pile and add some moisture, maybe add some nitrogen, get that process going again. You can use that material when you turn the pile to start a new pile. Like I said, that helps jumpstart a new pile if you've got some active compost to put in there. In this particular picture, we're turning that first pile out there at Curtis, so this was the first animal that was placed. That material we're taking down to the other end and using it to cap the pile at the other end. You can't see it in this picture. I've got a picture in a bit of some of the bones that were left in there. After 90 days, when we turned this pile, all that we had left were, rib bones, skull. There was a little bit of hide, but there was no flesh, left on that carcass at all. And I wish I had a picture of those of us that were out there. We were kind of crawling all over that pile, trying to look down in there and see what was going on, and there was really no odor coming out of it. It was pretty amazing. And so we were all pretty impressed with the minimal amount of effort that had gone into, building and maintaining this pile. It wasn't taking a heck of a lot of monitoring. They were getting some pretty good composting of that carcass. So like I said, that material, we can take it down, we can use it to start a new pile around a new carcass, or we can add it to other parts of the pile. Any bones that are remaining in there, this is a picture of one of the bones we pulled out, those are going to take a little while longer to break down, obviously. This picture is a bone after 90 days, like I said, and it was getting pretty porous and pliable. We could peel it, peel it apart, so it was breaking down quite a bit. You may never get complete breakdown of the bones in the pile, but once that process is complete, if you composted those bones several times and they're still left, at that point they become a waste material you can throw in your dumpster, you can bury it, whatever. We don't like to see that spread in the compost out on the fields. But as long as you're trying to continue to break those bones down, if you take them, when you turn the pile, try to collect those and place them next to a carcass that you're starting in a new pile, that's where the greatest amount of heat's going to be, and you're going to get the greatest amount of further decomposition of those bones. So here's kind of a rundown of potential problems, kind of a troubleshooting list. I'm not going to run through all of these for the sake of time, but certainly kind of the central theme on this table is that if you're getting odor or you're not getting that compost, that temperature up where it needs to be, your issues are going to be either too much moisture in the pile, not enough moisture in the pile, or not the right mix of carbon or nitrogen within there. So you may need to add bulking material to help aerate the pile and dry it out a little bit. You may need to add some granular nitrogen to help jumpstart that process a little more. Or you may end up having to open that pile up, add some material in it, kind of start over if that compost isn't operating the way it should be. So it's kind of a bit of trial and error, but this gives a good list of solutions if you're having problems with the pile going. Like I said, Department of Ag regulates composting of mortalities, and so within your proceedings, there's a list of their requirements. And one of those is that you begin processing that animal within 24 hours of finding it deceased. One comment that the DEQ made the other day at another one of these sessions was that if you start composting and a few days in you decide maybe this isn't going to work for me, or I don't really like how this is going, at that point you're really not allowed to take it out and bury it, because the burial requirement covered by DEQ requires that that animal be buried within 36 hours, I believe. So at that point you're kind of gotten outside of their boundary of being able to bury it. So their recommendation is you either have to take it out of there and take it to a landfill, or you need to finish the process that you started and go ahead with it and try to make it work. So that was an interesting point I hadn't thought of until they mentioned that the other day. If you're operating under a state DEQ permit for your operation, there is a modification that's required if you decide to implement composting where you haven't been before. There's no fee associated with that, but you'll need to work with your local DEQ representative or call the state office and kind of get some assistance on how to add that into your current permit. It does become part of your nutrient management plan. If you have a CNMP in place with the NRCS, again, it becomes part of that as well. So you'll want to work with your nutrient management planner or your local NRCS representative to modify your plan accordingly. As far as the nutrient value when that material is finished, just like manure, we want to see you test this product before you use it to apply to your fields. And so this kind of gives a rundown of how to collect a grad sample. You don't need to sample, you don't need to submit several samples from it, but you want to kind of go throughout that pile and get samples of your finished material, make a composite and send that in for analysis. And whatever you do for your manure analysis is going to be suitable for analyzing your compost as well. You're looking at nutrients so that you can properly include that in your nutrient management plan. Just a few additional considerations. Like I said, the large bones are not going to break down quickly, but you can help facilitate breakdown of those further by, when you turn it, take those bones and place them next to a new carcass so that the heat breaks them down a little more. It's probably going to take about 12 months to fully go through that compost process and get a mature product at the end. And if it's done correctly, the odor should be minimal and definitely not offensive. If it is, then there's something going wrong in the process that you'll need to address. So with that, I'll leave you with this. This is just an advertisement for a manure demonstration field day we're going to be holding in July in Lexington. And if any of you attended the North American Manure Expo a few years ago that was held here in Nebraska, it's going to be similar to that, but on a smaller scale. So I would encourage you to attend that if you're available. So with that, I'll take any questions you have.